Okay, so in this video I'm going to go over Q3. Q3 is the third standard on the quadratics test. You won't be taking Q3 until Thursday, October 4th. So on Thursday there'll be three parts of the test. You'll do Q3, Q4, and Q5. I have not had a chance to go over those problems from the study guide, so this video is just me walking through each problem, hopefully helping you be prepared for that portion of your test. So there's three questions on Q3 on the quadratics test. Each of them is asking you to solve a quadratic using a specific method. So the first problem is asking me to solve this quadratic by factoring. As soon as I look at this problem, you need to notice immediately that this problem, 1, is not in standard form yet, and 2 is not set equal to 0. So in order to solve, I need both of those things to happen, but I can take care of both of those things with one step. That one step is just moving this 15 over to the other side. So if I do minus 15 here and minus 15 over here, my negative 15 on the left side cannot combine with anything. It's not like terms with x squared. It's not like terms with x. So it's all just going to be written out as 6x squared plus x minus 15. And now that I subtracted it over there, I'm going to have it equal 0. So I solved both problems that I had. It's now in standard form on the left side. It's now set equal to 0, which I need in order to solve. So I'm now ready to solve this by factoring. I always check to see if there's a greatest common factor when I'm factoring. There's not. So when I look at this quadratic, I just know that it's going to factor down to be two binomials. Okay, in order to get 6x squared in front, my first term times my first term has to be 6x squared. So I've got a couple of options. That could be 1x times 6x. That could be 3x times 2x. I'm going to guess 3x times 2x to get 6x squared, right, knowing that I may need to go back and erase both of these and change it to 6x and 1x. Okay, next I know that this last term times this last term is going to multiply to give me negative 15. So I've got options again. It might be 1 and 15. It might be 3 and 5. I'm going to guess 3 and 5 just because those numbers are closest to each other. And I'm not putting the 3 on the same side as this 3 because that would create a situation where I could greatest common factor out of 3. And that's not, I know that's not going to happen because there was no greatest common factor from the beginning. So I don't know if this is right yet. So how I check is I'm going to check my outside. My outside is 9x. I'm going to check the inside. That's 10x. And I'm asking myself, can I use these two to make positive 1x for my middle? Yes, I can. In order to make positive 1x, I would need my 10x to be positive and my 9x to be negative. So my 5 times my 2x here, I'm going to need that to be positive. And my 3x times my 3, I'm going to need that to be negative. Okay, so I'm going to kind of get rid of my scratch work here that helps me factor that quadratic. You could have factored it by grouping as well. I'm not going to go over that in this video. If you need help with factoring by grouping, come and see me individually. But I'm not finished yet. Yes, I did factor it correctly, but if I'm asked to solve by factoring, there's another step I need to take to actually solve. That step is setting each one of these factors equal to 0. And then solving these two equations to give me two answers. So here I'm going to do minus 5 on both sides. Here I'm going to do plus 3 on both sides. So now I've got 3x equals negative 5, and I've got 2x equals positive 3. Here I'm going to divide both sides by 3. Here I'm going to divide both sides by 2. So my answer here is going to be x equals negative 5 over 3. And here my answer is going to be x equals 3 over 2. And just a reminder, most quadratics do have two answers, so this is a good sign. So we should have two answers here. And that is solving by factoring. Okay, next question. Number 2 in Q3 is solve using quadratic formula. I look at this problem, I immediately see that it is in standard form, it is set equal to 0, so that's good, I'm ready to start right away. Step 1, I need to identify what's A, B, and C in the standard form quadratic. So A is 3, not 3x squared, just the coefficient 3, B is 4, and C is 4. Okay, step 2, you don't need to do this on your test, but I like to write the quadratic equation out. just to make sure that I don't mess it up when I plug things in. This has to be memorized. It will not be given to you on the test. So please take time to have a note card and memorize this quadratic formula perfectly. If this isn't memorized, you have 0% chance of getting this problem correct on your test. All right, so now I'm just substituting in these three numbers into all of these places in the formula. There should be no x's at this point other than my x out front, because all I did was find the numbers up here, the coefficients, and I'm just plugging the numbers in here. So negative b means opposite of b, so opposite of 4 is negative 4. Plus or minus the square root of 4 squared. Minus 4 times a is 3, and c is 4. And that's all over 2 times a, which is 2 times 3. Okay, I'm going to simplify here. 4 squared is 16. I've got my negative 4 plus or minus out front still. I'm going to simplify all of this at once. That's negative 4 times 3 is negative 12. Negative 12 times positive 4 is negative 48. Okay, and this is all over, I'm going to do that as well, this is all over 6. Okay, next step. I'm going to do 16 minus 48, so I've got negative 4 plus or minus the square root of negative 32 all over 6. Okay, as soon as I see this negative underneath the square roots, I should immediately know that I'm now going to be involving imaginary numbers. The only way to have a negative under the square root is to involve imaginary numbers. That's why they were developed. So, off here to the side, I'm going to simplify the square root of negative 32. And I'm going to break it up into square root of 4. Sorry, I'm going to break it up into square root of 16 times the square root of 2 times the square root of negative 1. So what that does is that breaks off my negative so that these are going to be positive, taking care of that problem. And if you noticed, I originally thought it was going to be the square root of 4 times the square root of 8, where the square root of 4 would turn into the whole number 2. But right then, it dawned on me that there's a bigger perfect square root of 16 times the square root of 2. So we simplified radicals in class, but this process was from a previous set of notes. Okay, so now my square root of 16 is going to be the whole number 4. My square root of negative 1 is going to be I, and then I have the square root of 2. So I'm going to come back to my problem, and this is going to turn into negative 4 plus or minus my square root of negative 32 turned into 4i square root of 2, and this is all over 6. Okay, at this point, I always recommend that students, when you have more than one thing in the numerator and only one thing in the denominator, you break it up so that each of these is over 6. Okay, I believe it's a lot easier to see whether or not things are going to reduce when you put them each over. So I'm going to keep my plus or minus in the middle, and now I've got 4i square root of 2 over 6. Okay, now that I've got them separated, it's a little bit easier to see that it can be reduced. So here, a 2 can go into both. So I'm going to have x equals, that's going to be negative 2 on top, positive 3 on the bottom. I got my plus minus in the middle. I can't simplify inside a square root. That's kind of locked in, but I can simplify these numbers on the outside. So again, the 2 can go into both. So this is going to become 2i square root of 3 over 3. Okay, there is nothing else I can do to simplify that more, so I'm finished. If you had an answer of negative 2 plus or minus 2i square root of 3 all over 3, that means the same thing, it just put it all over 3. So that would be accepted as well. Okay, but you would have to reduce here to get full credit. Okay. Last problem in Q3, number 3. It asked me to solve by completing the square. I begin by looking at this. I see that it's not in standard form and it's not set equal to 0. So I'm going to start by fixing that. I'm going to do minus 24x on both sides. So I've now got 6x squared minus 24x plus 12 equals 0. So notice that did not combine with either of these, so they all got written out. Notice that I did write it in the middle. That keeps it in standard form. So now I have my standard form quadratic. I've got it equal to 0, so I'm ready to solve. And specifically, this one asked me to solve by completing the square. Okay, steps to completing the square. Step 1, I hate this c. I need to get rid of it. So I'm going to do minus 12 on both sides. I now have 6x squared minus 24x equals negative 12. Okay, I get rid of that because I'm going to create a new c on my side that will make this factor beautifully. But I'm not ready to do that yet. I cannot begin cutting in half and squaring until a is 1. So I need to factor out this 6. So now I have 6 times x squared. If I factored a 6 out of that as well, I would have minus 4x. I'm going to leave room for my new c that I'm going to create, and nothing changed back here. Okay, creating my new c. I take b, negative 4, I cut it in half, that's negative 2, and then I square it. Negative 2 times negative 2 is positive 4. Okay, what I did is I just changed the problem. I put in a c that I liked, but I'm not allowed to just change the problem unless I do it on both sides of the equal sign. So I didn't really add 4 over here. It looks like I did, but because of distributive property, I actually added 24, 6 times 4. So if I add 24 on the left side, I also have to add 24 on the right side. All right, so what I have left over here, 6, this is going to factor to be x minus 2 times x minus 2. So I'm going to write it as x minus 2 squared. And equal, over here, negative 12 plus 24 is positive 12. If the directions asked me to rewrite this equation in vertex form, I would bring my 12 back so that everything was on the same side, but it didn't. Since it asked me to solve, now what I need to do is get everything away from x. So my next step is going to be to get rid of this 6. Since it's 6 times this stuff, the inverse is divide, so I'm going to divide both sides by 6. So now these cancel, and I have x minus 2 squared, and that's equal to 12 over 6 is 2. Okay, next thing I'm going to get rid of is my exponent of 2. I do that taking the square root. A square root and a 2 cancels, leaving me with just x minus 2. I don't need the parentheses anymore because there's no more exponent. But if I do the square root on one side, I've got to do the square root on the other side. This is where I'm very worried a lot of people are going to forget. When we take the square root of something in an equation, we can't forget that there is a positive and a negative version of that answer. So I'm going to have plus or minus the square root of 2. If this were a perfect square like 4, then we would actually turn it into a whole number, but it's not a perfect square. If this square root could be simplified, then over on my scratch paper I would break it down and simplify that square root, but this can't be broken down, so I can't do that. Okay, last thing to do to get x by itself is to add 2 on both sides. Dalen, hold on, you need to stay in here. Stay in here. Okay, sorry about that. This cancels, and I now have x by itself. I've got positive 2 plus or minus the square root of 2. There's nothing else I can do to simplify that. So those are my answers. 2 plus that irrational decimal and 2 minus that irrational decimal. And that would be an acceptable answer. Hope that helps with Q3.
Done or not done?